Welcome to the Talking Reliability podcast, where the future of maintenance meets the power of sound. Hosted by Chris Hallam from UE Systems, we're diving deep into the world of predictive maintenance, asset reliability, and cutting-edge ultrasound technology. Whether you're on the plant floor or leading reliability strategies, pull up a chair, or better yet, grab your hard hat, because we're bringing you real talk, real stories, and real insights from the experts who keep industries running. Let's crank up the volume on reliability. And welcome to another episode of Talking Reliability with me, Chris Hallam. And today, joining me for today's episode, where we're going to be talking about data-driven maintenance, is a good friend of mine, Luke Grice-Lowe, the Director of International Business Development at MultiSensor AI. So, good morning, Luke. How are we?
How are we, Chris? All good my end.
Excellent, perfect. So, for those that don't know who you are, Luke, I mean, there's a lot of people do know you, but there'll be a lot of people that don't know you. Who is Luke Grice-Lowe, and what is MultiSensor AI? What's your background, Luke?
So, for all those that don't know me, for all those that do know me, I'm going to start off with apologising because I do come with a fun reputation. I currently work at MultiSensor AI as the Director of International Business Development. MultiSensor AI are looking at condition and monitoring platforms and how we bring that single source data integration, everything into one place, one clean platform, that single pane of glass. Background is I'm an ex-military weapons engineer. I did all the maintenance programs for weapon systems, laser guided missile systems. Then I moved into Amazon as a global reliability engineer and started building reliability strategies out across all different technologies. And then we started developing different maintenance strategy, and almost a spin on a few different strategies into one, and that's data-driven maintenance, which is obviously what we're going to try and speak a bit about today.
That's it, and that's where we kind of crossed paths, wasn't it? Probably about 5-6 years ago now, Luke, wasn't it? When obviously Amazon were looking at a form of condition-based maintenance program, looking at different technologies and that, and then we came together and looking at the ultrasound part of that, wasn't it? But this strategy that you put together, where were you before you started this journey? What sort of challenges were you facing day to day?
Well, it's been a blossoming relationship, obviously, between ourselves, condition monitoring, you name it, where we've gone. When we first started bringing in ultrasound, it was very much right, let's do it, let's see what happens. And then we very fastly learned that without the training, we are pretty much scattergunning money all over the place. So we had to take a different approach. We ended up doing a lot more training, ripping everything out and starting again. And then as we started getting more into ultrasound and then started bringing in thermography and all these other technologies, RME as Amazon at the time was still running, preventative maintenance. We were still using bits of predictive maintenance. We were still using reactive maintenance. We still were very much running calendar-based schedules, and it wasn't really fitting with the data approach that we were going to. And the way we wanted to move forward, if you think about it, the doctor-patient relationship, how many times does your doctor phone you to say, I need you to come in because you got a bum knee? Or how many times does he tell you, I need you to come in because I think you've got a headache today? And the idea was to switch it on its head and have the maintenance or the assets tell you when it wanted to see you. And that's where the vision started. How do we stop all this calendar basis, over maintenance, all these non-stop calendars raining down on people every 2 weeks? I want you to go and look at this piece of machinery every 2 weeks, no matter what's happened. And that's kind of when it started evolving, and we needed to start changing how we saw the asset. The asset's there to work. We're not there to keep taking it out for production. We need the best we can and the most uptime to ensure that coin a term that Amazon used a lot was that customer obsession, that customer small, customer first. And the only way to do that was to reduce their maintenance schedules, to keep it running as long as we can. And that's where we wanted the asset to tell us when it was having a problem. And then luckily around that time, we started developing Monitron. And Monitron became that gap that plugged the frequency of inspection gap for us. I think the easiest way to explain it became our low-cost, high-volume output, which we could put everywhere, keep tabs on things, and then we could use other technologies to start honing in. I think it started getting interesting when you put it against the DIPF curve and actually see what additional we can do with it. So we looked at that P to F and that point of detection and what we were getting from it, and started chasing it down. Because especially in logistics, these aren't, tens of thousands of pounds pieces of equipment. These are bearings, the belts that, when you break it down to the nuts and bolts, these are £20 bearing, £100 belt. You can't just keep pumping money at it. So the idea was, how do we get it as close down to that point to keep your cost to serve low? So if we say, take ultrasound as an example, we were changing everything out as 8 decibels and it was a lubrication or alignment fault, our parts cost goes through the roof. It wasn't manageable over time. So we started toying with different ideas on how we could incorporate different technologies to get us to different points and then remove the schedule completely.
Because that's it, isn't it, Luke? I was just going to say, interject there just a little bit, because, when it comes to these sort of programs, you see a lot of people that are trying to compare technologies instead of how you compare them, if that makes sense. And that's something that you guys have done very well, isn't it? Looking at vibration, looking at ultrasound, looking at thermography, and you guys looked at it in a different way, didn't you?
There's always that conversation is, right, if I'm doing vibration, why do I need ultrasound? If I'm doing thermography, why do I need oil analysis? And I think that was the biggest educational or cultural blocker that we had at the time. We're constantly asking finance for more money to innovate, to change these strategies. And it's 9 times out of 10, if we're getting success from one technology and you're going finance, well, actually, I want another 1.1 million to invest in this other technology, which gives me this little bit more, the conversation starts becoming more and more difficult. So that's where we stepped away from that single technology approach and went, right, our condition-based monitoring programs is one technology. It's all of them working together in unison. And I think one of the easiest ways that we actually sold it to, different finance teams, different RME leaders and all the people at the time or the key stakeholders was when you actually look at your decision tree for diagnosis. So the first one kicks off. You get current monitoring ping. Well, that current monitoring goes off. That could be anything on that asset. There's that many variables that are going to attribute to that current increasing or whatever's going on, is how do we define it down? So the first question you ask yourself, is it mechanical, is it electrical? But just with that current going off alone, we can't make that decision. However, if I had Monotron, which was our vibration technology, go off as well, and I had that anomaly, straight away I've halved my decision tree, because electrical faults don't cause vibration. So then we can start narrowing it down. And as Amazon is a very much data-driven company, you can start getting into your decision science and you can start looking at your chatbots, which was, assisted remedy. That was the idea, is how far can we get you down without tunnel vision in you? And we didn't want to cause tunnel vision for engineers by going, right, if we follow this all the way down to the decision tree, what the fault is and what the repair is. But actually in maintenance, as we all know, it could be 3 to 4 things that can cause that same signal, that same output.
So you're kind of looking at trying to kind of take away some of the analysis as such from the maintenance staff to kind of free them up a bit, I guess, there, isn't it?
Everything now, if we look at the skills gap within the industry as well, I think that's one of the main driving factors. If we look at the skills gap within the industry, how many people we've got coming in with the training, we need better ways to help them develop over time. And we can't have skilled engineers side by side with, passing on knowledge, as that is the gold standard, holding hands, monkey see, monkey do. It worked for the military perfectly. The military have used monkey see, monkey do for
a long time,
a very long time. But it couldn't work in the environments we were in. So if we could get, assisted diagnosis to work and almost become that hand on the shoulder, that guidance, it'd help them a long way. But you didn't want to take it too far where you created tunnel vision. That was trying to get a data scientist to stop with the data is a big battle.
No, absolutely.
You can try to take it as far as you want, but at some point we've got to let the engineer's experience take over.
No, absolutely. So, I mean, through this journey, you found what worked and how to kind of replicate that on site by site. But how do you deal with the challenge that is rolling out a standardized program across an organization the size of Amazon itself on a global scale? Because that's a large number of sites. We're not talking about 20, 30 sites or facilities in a company that you're replicating. You're talking hundreds of sites, aren't you?
I think today we're at thousands. So these programs cover near enough every building across every continent, subtracting Antarctica with the penguins. They don't exactly need condition monitoring, but everywhere else there's always a use case. But processes, frameworks, that builds scalability. If you get your process right and you get your framework right when you're developing, everything's. We say it a lot. Pretty sure you agree. The key to condition monitoring is repeatability. So how do you get repeatability across, thousands of sites? I think it's like 30 odd countries, 6 continents. How do you do it? Luckily, engineering and maintenance is all one language.
Absolutely. So also with that then, Luke, I mean, you're looking at a collecting data, creating a data-driven maintenance program. You're using kind of off-the-shelf technologies, you could say. What was key to taking those technologies and adapting them to fit your needs?
When you look at condition monitoring, one of the things that are always forgotten is the fundamentals, the back to basics. So, what does your criticality assessment tell you? What are your failure modes telling you? Is it mean time to repair, mean time between failure? Does that fit into my big picture of maintenance, what I want to spend? So when we're looking at return of investment and we're using these off-shelf products, I don't want to be spending $15,000 on a piece of equipment to monitor a bearing that cost me 20 to repair, less than 30 minutes to get it back up and running. But in labor, to do that inspection day, that isn't fixed monitoring, it's going to cost me like $600-700 per month. The math doesn't add. Math is going to tell you 90% of your decision, but I'm going to do it or not.
Absolutely.
So that always got to bring it back to them failure modes and your criticality assessment. If you haven't done a criticality assessment first, that's always got to be step one.
Absolutely. And that's something that we've seen reiterated across quite a few of these podcasts, is talking about the fundamentals, the basics. People like to kind of see the bright, shiny things and go, oh, there's that's going to cure all our problems. But actually don't think about the basic bits first and get those bits right, and then looking at afterwards as well with those technologies, things like root cause analysis, identifying what caused that issue. And is there a way that we can remedy that to actually remove that from happening again in the future, isn't it?
I find it interesting though, because if you look at a criticality assessment as something as simple as, right, tell me your severity, tell me the occurrence, tell me, all this, and then give me a number at the end versus all my other. If you then use your condition monitoring data to bring back in, that mean time to repair, mean time between failure, what anomaly points I see, you almost have a self-developing criticality assessment. So it becomes a live working document. And I've always thought if you apply a maintenance strategy against the criticality, and then as that maintenance strategy starts improving it, that criticality starts coming down because you're not getting the high severity, high occurrences. Teams are becoming more responsive, so that repair time starts coming down. Then you start getting a new top offender, and then that new top offender starts getting that additional investment into that maintenance strategy. And that's where it starts becoming really interesting. If you take things like, your criticality assessment, add the data, add the live data, let's see what changes month on month. Do that reassessment. If you look at the P2F curve and you add that to, I don't know, let's say supply chain. Supply chain's a great one. Do I want to store 900 motors in my warehouse and I've only got a 10 meter by 10 meter cage? No, I don't. Does it do same day? No. Okay, so ultrasound's gone off. We see the degradation curve over time. So we predict in, 7 days, we're going to hit that 32 decibel mark. And we're going to need to make that repair, that intervention, or whatever it is. What's my lead time look like? So straight away, you get a system now that's taking your on-condition data for that asset or that total asset condition. And now it's going, right, what are all my other variables, or what are all my other non-engineering variables? My supply chain is 2 weeks out. So actually at 60 decibels, I'm going to make sure I've got one in. And then that way you start controlling your cost to serve as well. We're not holding millions and millions of dollars worth of parts in a store's cage that are just there aging, not getting turned over, no maintenance going on.
No, that's it, and that's exactly the description of like a predictive maintenance program. You're predicting what's going to be happening, but I think that you took it to another level again there, didn't you, with this data-driven strategy? Because if you look at a predictive maintenance program, you're still using predictive technologies, but you have those being used on like a time-based frequency because you're collecting the data based on time. But you guys started doing things with the data and adjusting that frequency. Is that correct?
Yeah, so I think a good example is if you look at usage-based time maintenance. So instead of taking that calendar every 2 weeks, you actually look at the cycle run times. So let's say that 2 weeks. However, instead of scheduling maintenance for that 2 weeks, it basically goes, right, check my total asset condition. And then, right, you've got no anomalies, you've got no current monitoring spikes, you see no, ultrasound, you see no vibration, thermography increases. Push it out. You don't need to continue to. You used to see it all the time, and it used to paint a picture, especially when the first success stories used to come in through these technologies. The amount of faults you have post maintenance, and the increases you see post maintenance, whether that's someone didn't put the guarding on correctly, they forgot to align, belt was over tensioned, and you start building this picture as the more you interact with something, the less reliable it is. So if you're constantly going in and doing intrusive maintenance every month on a PM schedule, why? What's the benefit? What are you hoping to find? Because none of the data shows you that you're going to find what you're looking for.
Yeah, I would absolutely agree with that. And, I can imagine you can sympathize with this being ex-military as well, that any sort of maintenance was time-based. And the amount of times that you had something that was working perfectly fine, you followed that time-based maintenance, you put it back together, and lo and behold, half an hour later, it's fallen over. Would it have fallen over if we touched it? Probably not.
I think you can make that military draw with, if you look at weapon systems and you go records of rounds fired, that is your time-based maintenance. You're waiting for 1,000 rounds to go through that barrel before you drop a gauge. So that's your dropping the gauge is now your condition monitoring, because you're not going to do anything with that barrel until that gauge fails. So no go gauges. Yeah. One of the military's best tools. If it fits, get rid.
Yep, absolutely. Yeah, absolutely. That is, and that's where this is going. I mean, if we look at this is a change in reliability culture as well that we're talking about here. Did you face challenges with buy-in on this sort of approach? And what's it looking like, from when you first tried to instigate this to where it is today? Have you seen a change in culture shift or any challenges?
I think you do. I think, but with every program, everyone hates change. Everyone, engineers love routine. Maintenance engineers love routine. They love coming into work and knowing exactly what they're going to do. No one likes reactive work. And if you do, you're probably in the wrong job, because you're there to make sure that it's running. Everyone likes maybe the bit of excitement is, right, quick, let's get it back up. Let's play the hero. But at the same time, the hero stands where he doesn't have to do anything at all. So you're always going to have that cultural disruption. But I think the biggest disconnect comes when reliability becomes a job title. Reliability isn't a job title. Reliability is almost like a consortium. That's the best way to look at it, is different stakeholders from different job roles all looking at the same business objectives, whether that's reducing cost, whether it's increasing uptime, that's engineers, finance, HR, throw them in there. That is a diverse perspective that no one's going to realize, that still has an engineering impact. When you look at training, culture, retention, it all still comes into reliability as a whole.
Yeah, absolutely. It's every department within an organization that is responsible for that. It's kind of like that, like health and safety is everyone's responsibility. Reliability is everyone's responsibility. Yeah. But because you then put it on a title, everyone looks at it and goes, well, that's that responsibility. It's nothing to do with me. And then when they ask for something from that person, then they don't approve it because they don't understand it. They're not taking responsibility for that reliability journey, are they?
I think that's where it gets interesting, because the conversation has to change as well. So we can sit there as engineers and speak engineering jargon and we can hit it, but it goes, over the finance's head. or you've got an IT person that's part of your networking stakeholder to make sure that all your IoT devices are all connected, and you're looking at your collection from a data point with your data science teams and your research scientists. So having that ability to change the conversation to fit the stakeholders in the room of when you need the engagement, what needs to happen and why, it's like being a multilinguist. I think that's the easiest way of putting it. You speak many languages.
No, absolutely. Because, like I say, you tailor it to the conversation of that department. Like, when you talk about health and safety, every different department will have a different responsibility under that health and safety. When it comes to reliability, procurement, accounts, HR, engineering, maintenance, all have a remit under that reliability umbrella to fit. But again, it's part of that education process as well. How many times do you do some sort of reliability based training, but it's just the engineers or maintenance that are in there? Why are we not having a conversation or training based on reliability in finance and procurement, in HR and everywhere else as well? I mean, I don't think that there is actually anything out there that does that. And I think if we had that education, it wouldn't even need to be very big or very long. But if we had that, how much would that help and benefit in these sort of programs?
It's one of the things that I spent most of the time when I first got this global role. I was used to doing condition monitoring programs on a small scale, 1 to 2 sites, regional, 6, 7 sites. Every now and again, you go out to a site across Europe, lend a hand. And I knew when I went into this global role that I understood the reliability, the maintenance engineering. I understood that part. I spent the first 6 months in my new role learning finance, legal, networking, IT. So when I knew I needed the help and we sat that stakeholder review, I knew what I was talking about, or at least I could engage the conversation to the point where, come on this journey with me, don't fight me.
Absolutely. Absolutely. And I mean, for the listeners that are out there, listening to this, Luke, and there'll be some people out there thinking, I really want to do something like this in my organization. I've maybe hit too many roadblocks or I don't know where to start. I mean, what advice would you give to people that are looking to try and start some form of predictive maintenance program? What would you tell them to kind of focus on or look at in the first instance?
Well, sticking to the maintenance side, criticality is the first point of call. If it doesn't start with a criticality, you throw money at a wall and hoping something sticks. That's the main one. Criticality drives where your investment's going to go. Then you're looking at your return of investment side. Is it worth doing what we're doing? Can I afford to? You can look at an easy one and split condition monitoring into two. Go fixed and route based. Right. Can I afford labor intensive walking around, taking the data, collecting the data and all that? Or is it more cost beneficial to have a sensor doing that? But I'm going to tend to pay more of a higher CapEx than I am going to pay a higher OpEx with route based.
Mm-hmm.
And that's where one of the main conversations, but then culture's your big one to get anything started, getting the right people in the right place, having the right conversations. And I always find doing a workshop, people roll their heads and look at another workshop, where we're going this time. But getting all them people in one room and having open and honest conversations about what they think their problems are, 9 times out of 10, what you'll all find is it all comes back to the same problem. Finance will be there. Well, I lost, I don't know, 20,000 this month in labour overtime. We've got 20,000 hours worth of downtime. Oh, actually, our maintenance schedule's way too out. You got planners coming in going, I haven't got enough labour. Well, actually, the root cause all comes back to the same thing. We haven't got an effective strategy for the assets we've got out there. So when you start looking at labour effectiveness, that's a broad spectrum. That covers everyone: HR, finance, engineering, planning. Every man and his dog is all in charge of labour effectiveness. I think a good military term, and I've always took this out of the military with me. If I walk into a workshop and all the engineers are sat down and doing nothing, my plant must be pristine and perfect. Everything's running.
I've used that same terminology myself.
Where if I can't see an engineer anywhere in sight, all hell must be loose.
Absolutely. Absolutely. No, and that's right. I couldn't agree more with you. And I do hope that people that are listening into this are making notes of this, because I think there's a lot of really interesting things that they can do. And as you were saying there, get them together for a workshop. Funny you should say that, Luke. I mean, there's a perfect workshop coming up, or an event called Talking Reliability Live on the 2nd of October. I think you might be there. Is that right?
Sounds very interesting. So if I'm not, then it can't be that interesting.
No, I know. And I guess, if you are there, then it must be really interesting. And, it's going to be great for people to pick your brains at. And I'll plug it right now, because that's the 2nd of October in Warrington in the engine rooms. It's going to be Talking Reliability Live. Website is www.talkingreliability.com. There's going to be myself. Luke's going to be there. Well, he's promised me he's going to be there, talking about all these sort of good things, along with lots of other great contributors for the day. So sign up for that. There's still spaces available, and we look forward to seeing you there as well. But Luke, we could go on for a long time. There's so many things. How many hours have we spent talking about things that bug us in reliability?
Oh, tell you, there's many hours gone into that, especially over a nice cold fermented beverage.
Absolutely.
One of the best pairings with Talking Reliability I had.
Yes, that's right. And I think we came up with a new side discussion about drinking reliability at some point as well, didn't we? So
drinking reliability may be the future. Stay tuned.
Absolutely. We'll keep that one. We'll keep that one side. I might have to get the website for that one right now. But no, Luke, do you know what? It's been a pleasure. I wish you all the luck with your new role at MultiSensor AI. Like I say, people can come and see you at the Talking Reliability event in a few months' time. But yeah, thanks for tuning in, everyone. And thank you, Luke.
Appreciate it. Thanks for having me. Enjoy the rest of your week.
Cheers, guys. Take care. Bye-bye.